Hey everybody, my name is Emma. It's 10 a.m. and you're listening to Living as a Physicist. Today is September 5th, 2018, and this is a very special day because we prepared a lot of surprises for you. For everyone listening from the comfort of your houses or from your cars or phones, this is especially for you all. So, let's get started. Our first segment of the program will consist of a mini-game, and the winner will get an amazing chance of meeting the magnate, the amazing, the successful, and handsome Elon Musk. The first one who calls the next number will have the opportunity of meeting this great man. Okay, everybody ready? The number is 771-3430-864.
Kitty cootie gotta call this number now. If you wanna check it out, just do yourself a favor and just call this number now. Call this number now.
Oh my goodness, we received the first call. So, what's your name, Oidofewa?
Good morning, my name is Alice.
Hey Alice, this is your moment. You have to answer 4 relatively easy questions. If you can achieve this, you win! Any questions?
No questions, it's all good.
Okay, I hope you know the hierarchy of the 4 fundamental interactions that govern how objects or particles interact and how certain particles decay in nature. According to Encyclopedia Britannica, the fundamental interactions are characterized on the basis of the following 4 criteria: the types of particles that experience the force, the relative strength of the force, the range over which the force is effective, and the nature of the particles that mediate the force. Basically, the basic feature in this field is the occurrence of forces that keep matter together. The question is, tell us the key points of the strongest force.
Well, in the first place we found the strong nuclear force. In general terms, it's a very strong attractive short-range force that binds the protons and neutrons in the nuclei of the atoms together. It is the strongest of the fundamental forces, but acts over a very short distance. This force is what binds quarks in combination, so they can form protons and neutrons and many more exotic subatomic particles. Quarks are a group of fundamental particles that are always bound to other quarks. In this way, a proton consists of 2 up quarks and a down quark, while a neutron consists of 2 down quarks and an up quark. In summary, strong nuclear force tries to bind the nucleus together.
Wow! Are you sure you didn't look that up at Wikipedia?
No, of course not.
Hey, Fewa, don't worry, I'm just kidding. Let's continue with the next one. Explain us the 2 aspects of electromagnetism.
When talking about the electromagnetism, the science of charge and of the force and fields associated with charge, the 2 aspects involved are electricity and magnetism. The electric force, in particular, is responsible for most of the physical and chemical properties of atoms and molecules. On a more familiar scale, electric phenomena are responsible for the lightning and thunder accompanying certain storms. In the magnetic field, the charges can either have negative signs, such as for the electron, or be positive as for the proton. It is the fundamental interaction that binds electrons to nuclei to form atoms and binds atoms together in molecules and solids. In other words, this force is the one that originates the attraction and repulsion forces.
Nice, Alice! I'd like to add something for our friends listening out there. About the electromagnetic force, you should remember that equal charges will repel each other. A positive and a negative charge will attract each other. And about the interaction of the magnetic fields between 2 charged objects, you have to know that 2 magnetic north poles or south poles will repel each other. but a magnetic north and a magnetic south pole will attract each other. Now, here comes the hard one. Describe the force that has a short-range force that acts on the quarks that make up protons and neutrons.
I'm not pretty sure, but I think it is the weak nuclear force. It is much weaker than the electric, but still much stronger than gravity at a short distance. This force acts over an extremely tiny distance and is the cause for beta decay in atoms. The beta decay is a particular form of radioactivity which occurs when a neutron breaks apart into an electron and a proton. The electron gets kicked out of the nucleus as radioactivity while the proton remains in its nucleus, changing the original atom into a different element. For example, NASA explained that without it, the sun would not shine because it allows protons to change into neutrons, allowing for nuclear fusion.
Really? You absolutely deserve the prize! Can you just share with us your knowledge about the gravitational force?
Yay! I really want to meet him! Sure, no problem! It's a very weak, attractive long-range force of unlimited range that exists between any two objects possessing mass. The first quantitative theory of gravitation based on observation was formulated by Isaac Newton in 1687, who also formulated the equation that described this phenomenon. Any two objects that have mass attract each other with a force we call gravity. The equation describes that the force of attraction is proportional to the mass. If you double the mass, then the force doubles. The force also depends on the distance. It is an inverse square law because when the distance gets larger, the force gets smaller, and when you triple the distance, the force decreases by 9. If you make the distance increase by 4, then the force goes down by 16. This happens because of the principle of the square law. Moreover, this fundamental force controls the trajectories of bodies in the solar system and elsewhere in the universe, and the structures and evolution of stars, galaxies, and the whole cosmos.
Congratulations, Alice! This is an epic moment in living as a physicist. In a moment, we will contact you so you can have the information of when and where you will be able to meet him.
I'm so glad I had this great opportunity. Thank you so much, Ima.
Thank you, Alice, for participating in this game. Until next time. We're going to have a small cut, but we're coming back in a second.
You ain't getting over him. I got no rules, I count 'em. I got no rules, I count 'em.
And we're back! The song you just listened is of one of our favorite artists, Dua Lipa. So, guess what? She's here with us right now to be a part of a new section. Ladies and gentlemen, please welcome Dua Lipa!
Hey guys, thank you so much for having me here.
So, I guess a lot of you are asking yourself, what is Dua Lipa doing in a physics program? Well, it turns out that she loves physics, don't you?
Yeah, I think physics is like really important to understand how the world works. And it was my favorite subject back in the day when I was a kid, so I might remember some concepts that I learned.
Well, this is your lucky day because we have prepared some questions for you. Let's see how much you know.
Oh, bloody hell. I'm so nervous, but okay. Okay, I can do this.
Perfect. Isn't she lovely? The first question is easy. So, what is mechanical energy?
Yeah, I know the answer for that. Mechanical energy is the sum of kinetic and potential energy in an object that is used to do work. In other words, it is energy in an object due to its motion or position, or both. Mechanical energy is constant in a system that has only gravitational forces, or in an otherwise idealized system that is one lacking dissipative forces such as friction, an air resistance, or one in which such forces can be reasonably neglected.
Alright, but what is actually work?
Work is done when a force acts on an object to cause it to move, change shape, displace, or do something physical. For example, if I push a door open for my dog to walk in, work is done on the door by causing it to open.
Maybe you could tell us some everyday examples of when this energy is manifested.
Well, for example, if I was in a roller coaster, which is like nearly impossible because I hate them, but in the case I was, and I got stuck on the top, then I would have a quantity of potential energy, which would become my mechanical energy. But if the roller coaster started going down, then I would not only have potential energy, but also kinetic energy, which I would sum up to get the mechanical energy. What else? Well, actually, guitars are the instrument I'm in the most contact with, and the main difference between an acoustic and an electric guitar is how the electric one uses electromagnetic fields, so the chords can generate sound. Because unlike the acoustic ones, the electric guitar doesn't have a sound box. Therefore, the vibrations from the chords need electromagnetic fields in order to produce sound.
Wow! You're perfectly mastering the topic! Now, can you give me one example of the transformation of the energy?
Well, an energy transformation is the change of energy from one form into another. And the law states that energy cannot be created or destroyed, but only changed from one form into another or transferred from one object into another. One example could be when I'm in my car, when I'm driving and there is an internal combustion engine, because the fuel is being burnt and the chemical energy is converted into mechanical energy, and the mechanical energy is then used to set the car in motion.
One last question, please.
Yeah, mate, I am really having fun here with you.
Thank you. You can come whenever you want. Do you know any application of technology for the use of mechanical energy?
Yeah, I do. A hydroelectric plant converts mechanical energy into electrical energy, and the mechanical energy of the water falling down is used to rotate the turbines that are present at the bottom of a waterfall, which generate electricity. Also, steam engines run on heat energy, which is converted into mechanical energy, which is used to run locomotives.
Thank you so much for being here.
Yeah, it was lovely.
We have one last petition from the public. Could you please sing us a song? We are really excited to hear your voice.
Anything for you, lad.
Hey. Oh, baby, come on, let me get to know ya. Just another chance so that I can show that I won't let you down and run. No, I won't let you down and run. 'Cause I could be the one. I could be the one.
That's everything for today's program. I hope you have enjoyed it as much as I did. We had a lot of fun and we learned so much about physics and the world around us. So today was just wholesome. Next time we'll have even more prizes and many guests. So stay tuned. Until next time. See you later, alligators.